So, for today's class, when we look on our Algebra 1 Teams page and we go to the current week's channel, we see that the only work for today is page 2 of week 8 problems, questions 5 through 8. And remember, we could find support for this, right? From both today's recording, which will be posted below this meeting, right? Yesterday's class recording, which is right here, right? In addition to the Khan Academy video that was on this topic from Tuesday, right? And the Khan Academy practice. So we could use all these things that we should have done earlier in the week to support us through this working with problems using the quadratic formula, right? Which I really stress because it is a very important topic in mathematics. Right? It was something that'll come back time and time again. Just in general, this whole concept of working with quadratic equations and solving them. So let's get started doing page 2 of week 8 problems, questions 5 through 8, right? If you recall, anyways, on page 2. Right, so we did problems 1 through 4 yesterday. Then today we're going to do 5 through 8. So I'm going to start us off with problem 5, and then I'm going to jump to problem 7, so leave some space for problem 6. Right, and then you guys are also going to do problem 8. So I'll do 5 and 7, you guys do 6 and 8. So, so we have our equation, and remember, in order to use the quadratic formula, one of the sides has to equal 0, right? So we see here that this side equals 7x, so we got to move everything. We got to either move the 7x over to the other side, or we got to move everything else to the 7x side. And it seems a little bit easier just to move the 7x over. So we'll say minus 7x and minus 7x from both sides. Right, 7x minus 7x gives us 0 like we want. And then we have 10 minus 7x minus 2x squared, right? We can't combine the 7x with a constant or an x squared, so we'll just put it in the middle. So now, right, just to make it easier for ourselves, in order to get it into normal form where it goes, we want it to go x squared x constant, right? So we'll put the negative 2x squared first, right? The negative stays with it, then minus 7x. And since this is a positive 10, we're going to say plus 10. So now we know that our A is negative 2, our B is negative 7, and our C is 10, right? When we get it into the normal form of x squared x 10, our A, B, and C are just the first number, second number, third number. Right, so now we have enough to plug it into the quadratic formula, right? So we'll say x equals, right, instead of remember this negative we could think of as the opposite. So x equals the opposite of, and instead of b, we're putting in negative 7. Plus or minus, instead of b squared, we're saying negative 7 squared. Minus 4, and instead of AC, we're saying negative 2 times 10. Right? Over 2a, we're saying 2 times negative 2. So now it's time to whittle this down a little bit, right? The opposite of negative 7 is positive 7, right? Plus or minus, and we got to simplify inside the square root. Right? We have a exponent multiplication that we could simplify. Negative 7 times negative 7 is 49. Right? 4 times negative 2 is negative 8, and then negative 8 times 10 is negative 80, and 2 times negative 2 is negative 4. So now, right, we have minus and negative, right? or we could also think about this as the opposite of a negative. So this is going to be combining two positives together. So it'll be like 7 plus or minus the square root of 49 plus 80 all over negative 4. And then 49 plus 80, right, we know is 129. So we get 7 plus or minus the square root of 129 minus 4. So now, right, you might be trying to simplify it further like what we were doing the other 2 days, but there is no square root of 129. The closest two square roots are the square root of, is the closest two numbers that multiply that square to give us a number close to 129 is 11, right? 11 times 11 is 121, right? Which is too small. And then if we go up to 12, right? 12 times 12 is 144. So that's too big, right? And we don't see any decimals here. So it can't be any number in between 11 or 12 either. So there is no square root of 129. So if you want the precise mathematical answer, you could actually just stop here. And you could say, right, this is your answer. You could just say 7 plus or minus the square root of 129 all over negative 4. If you prefer working with decimals, right, or if you just want to have that whole number answer, maybe you're doing this for a word problem, right? And they want to, like, for a word problem, like, you know, they want a decimal answer. If they're asking, like, how many, like, feet are you going to need, right? You don't want to say, like, 7 plus the square root of 129 over negative 4 feet, because we don't even know what that's close to. Like, is that close to 5? Is that close to 3? Right? What numbers are these close to? So we're going to have to plug it into a calculator. So let's get out, go to Desmos.com, and we're just going to type it in exactly like we see it, but we have to do it 2 times, one with plus and one with minus. So first we have 7 plus, we got to get the square root of 129, and then we got to make it a fraction. And if I just say, right, a fraction here, it'll do it inside the square root, which is not what I want. I could, right, click over here, and now I'm out of the square root, and I could do it, but, right, then it doesn't put it over the 7. So you're going to have to, like, highlight it all, right? We were saying we want to divide all of it by negative 4, right? And we get negative 4.58945411729. And we're going to do it again. So we're going to say, right, 7 minus square root of 129 all over negative 4. And we got 1.089. So we're going to round, right, say this is negative 4.59 and say this is 1.09. Right, and then we got our 2 answers. So the next problem. So remember, we're skipping 6. So leave some space so that way you could do that problem afterwards. And we're going on to 7. So, right, this doesn't look like it's in the right order, right? It's not x squared x number, and, right, it doesn't equal 0. So before we mess with the order, let's make this side equal 0 by subtracting 8 from both sides, right? And here we can combine the negative 8 and the 6. So, right, because they are like terms. So we get negative 2, right? 6 minus 8 is negative 2, and then everything else drops down. Minus 4x plus 3x squared equals 0. Right, now we got to get it into the x squared, x constant order. So we're going to put the 3x squared first, right? Minus 4x, and then minus 2. So now we know what our a, b, and c values are. Right? Because remember, it's just going to go in the orders that we see. A is 3, B is -4, C is -2. So now plugging it into the quadratic equation, we get x equals the opposite of -4 plus or minus, right? Instead of b squared, -4 squared minus 4, and instead of AC, we're going to say 3 times -2. And instead of 2a, we're going to say 2 times 3. So now to whittle this down a little bit, right, we're simplifying it. We want to get it in its most simple form. The opposite of -4 is +4. -4 times -4 is 16. And then, right, 4 times 3 is 12. And 12 times -2 is -24. So we have 4 plus or minus the square root of 16 minus -24 all over 6, right? Because 2 times 3 is 6. So now, right, we have minus and negative, so let's change that to a plus. So we have x equals 4 plus or minus the square root of 16 plus 24 over 6. And now it's 16 plus 24, we could figure that out pretty easily. It's just going to be 40. So we have x equals 4 plus or minus the square root of 40 over 6. Right? And now this is the most simplified form. Right? Because, once again, we're in a situation where we don't know what the square root of 40 is. Right? The square root of 6 times 6 is 36. 7 times 7 is 49. Right? 36 was too small. 49 was too big. And it can't be any number in between either. So you could either say this is your answer, which is totally acceptable here, right? Because remember I said that you, like, in situations where it's a word problem or where you're expected to give a decimal approximation, right? Here, it's just a mathematical equation. Like when you're solving for x, it's usually assumed that you're just finding the most simplified form. But if you want to, right, figure out the decimals, right, we could go on our calculator back to Desmos.com. Okay. And then we're just going to type it as we see it, right? 4 plus the square root of 40 all over 6 to give us 1.72, or 4 minus the square root of 40 all over 6, which gives us -0.39, let's say, right? 1.72 or -0.39. So those are the two right, decimal approximations. So whenever we get an answer like this, you should know that you can't factor this, right? Using the quadratic formula is the only way that you would have been able to solve this problem, other than completing the square, right? We haven't solved equations by completing the square. But the main point to note is that this is one of those examples where you wouldn't be able to factor it, right? The reason why is because you got to multiply the first and the last number together, right? You get -6, and then we got to find a pair that multiplies to -6 and adds to -4, right? And there's no numbers that multiply to -6 and add to -4, so you won't be able to create the generic rectangle, and then you won't be able to solve the problem by factoring. So in situations like this, we got to use the quadratic formula. So, and also the good thing about the quadratic formula is that it's safe and it works every time, right? And even some quadratic equations don't have a solution. This will tell you if it doesn't have a solution, because, right, you'll get the square root of a negative, which just tells you no solution. So that's it for today. Remember, if you haven't already completed the Khan Academy work, or the problems that you guys are supposed to do of this set, now would be a good time to do that and catch back up. And with that, you could log off.